Lesson 3 is about modeling complex systems. And we're going to be talking about a couple of things. First of all, on this example of the rifle, I'm going to try and explain how to achieve complexity in your designs. We're going to talk about some additional tools in Fusion 360, such as components, joints, and contact sets. These, for concept art, they're not as important, but it's still good to know to check your design and function and movement, making sure that at least your mesh is going to be easy to animate. And then we're going to go ahead and try to model this rifle for the exception of the scope, because we already did the scope. Maybe not exactly this rifle, because I'm trying to achieve this in the smallest amount of time possible, but basically something like a shortcut, an iteration of this gun. It's not going to be exact, but of course good practice is when you're training yourself in Fusion 360, good practice is to model as close as possible, because you're solving very particular tasks, and then you're learning new ways to model, and they will help you not only solve similar tasks in future, but they will help you expand your design library, so to speak. Speaking of which, we're also going to talk about references, because this gun is going to have several references in order to understand the complex shape. But let's talk about how to achieve complexity in your design. First of all, I kind of made a list of rules that I like to follow. They are not necessarily universal, but it's something that you can see in most of the designs and products that are manufacturable. So the first is modular design, which means that this whole weapon is not a solid piece. It's modular, and I would describe it as, this would be module 1, which is a scope, and then this is a separate piece, which is like a separate module, which means this is being modeled separately, this is being modeled separately, but not everything is as straightforward. I don't know about this grip, maybe we'll model it, but that would definitely be a module, like a separate component. And then this would be separate, and this would be separate as well. But again, because not everything is straightforward, to help this get to the final faster, it looks like this whole lower receiver / bot stock is a solid piece, but I'm gonna break it down and then connect in order to make it easier. So I feel like it makes sense to model this piece first and then model the handle separately, because just in this particular case the handle is very straightforward. It doesn't have any intricate plane changes from the front or back view, so it's going to be almost as easy as just an extrusion. And then this piece as well, we're going to try and model separately, again using sketch. So this, if we're talking about the lower receiver, we're gonna do 1, 2, let's do letters A, B, C, and then this would be kind of part D when we're gonna split that, and this is gonna turn into a separate module, so to speak. And plus, we already have the scope, so I'm not gonna do the scope. So the next thing that is kind of important when you're looking at a design is symmetry and asymmetry. This gun, more than likely, for the exception of this piece, we're gonna call it E, it's symmetrical left to right. So if we're looking at the gun from the front view, it means that this is the axis of the symmetry, and this is going to be left and right. So the gun, whatever the design is, it's symmetrical. So a lot of times when you're modeling something complex, let's say you're modeling this handle in sculpt instead of the actual body representation mode, solid modeling mode, it only makes sense to model like one side and then mirror it to the other side. But also, if this gun is symmetrical left to right, but top and bottom, obviously it's not symmetrical. So you will notice that when you're designing something, this is your instrument to either make the design more believable or more complex by controlling your symmetry and asymmetry. Symmetry can be kind of like this planar, so left and right, top and bottom. It can also be radial, so this piece in particular, we're going to call it F, has radial symmetry, which is used a lot in Fusion 360, which means that it's similar, right? Now, the next thing I want to point out as another rule is hierarchy of forms. We can see that the piece, the lower receiver, which is represented by A, B, C, and D, is just one general shape, and it's kind of simple and straightforward. We're going to take different color and point it out. For the exception of the piece that is D, I would say, because D gets more complex. So this is one big kind of simple shape. At the same time, it's not as straightforward. You can see some intricacy in design. Obviously, it has a very complex profile. It's not just this from the front, and we're going to use the reference to take a look at that. But it's still, let's just say it lacks surface detail, which is good, because when I say hierarchy of form, all I mean is really the 1, 2, 3 read, basically saying that 1 is big shapes, 2 is medium shapes, 3 is smaller shapes and surface details. So 1 comes first. It's going to be big, very clear, easy to understand shapes that take a lot of space of the design. Medium details take smaller amount, so they take like a smaller footprint on the design. So the smaller parts here can be this scope mount or any other, like it can be a Picatinny rail, doesn't matter. And then this grip, the barrel, and then the smaller pieces, the number 3 in the, so this is 1, 2, 3 read, and you read it from big shapes to medium shapes to surface detail. So this is the first read. This is the general shape you're looking at. Then you start noticing medium details. And then once your eye starts to pick out little individual details, this is the surface detail level. All kinds of nuts and bolts and various ways to attach elements to each other. All these little details, screws, trigger and stuff. Then all those kind of like little chamfers and little tiny parts and pieces. So this is pretty important to be able to control this. Basically, if your design is, even if it's a very simple shape like a cylinder, but then you overload it with surface detail, the read that you're going to get is 3 is going to be overpowering the big shapes. Which the read is going to be like basically 3, 2, 1. The good read is 1, 2, 3. This is the order. But if you're taking that over detailing something, the read is likely going to be like 3, 1, 2 or 3, 2, 1, which is, in my opinion, it's not a good design. So even though we're talking about complexity, it needs to be controlled. Now, the next thing is repetition and reusing elements. Usually this comes in the 3 reads, so in the surface details, taking all the nuts and bolts as an element that you're repeating, it unifies your design. But at the same time, I like to apply this rule to the way we're looking at the overall flow of the shape. So for example, this whole gun, let's turn this off, has this clear design line right here. And then if we had to add more design to it, like this is kind of like the general flow of things, right? So there must be some rhythm. It adds some rhythm to the detail. So when you start adding detail, you have to repeat that flow and like mimic that rhythm. So like the details that you're cutting in or something, they need to be sort of following the general design. So for example, if we needed to kind of add the lattice system to the stock to make it lighter, although we can't because it's housing the mechanism, but like let's say we have to, you have to be riffing off of the existing general like flow lines, and this would be the part we're gonna take out either completely or build the lattice system out of it, something like that. Basically just needs to have that repetition of the same design lines. So another important part that I like to talk about is, I call it industrializing, literally meaning like you're adding a layer of believability. It's all in the medium and third read, where we're talking about a little bit of functionality here and there. If we have that grip, it has to be 2 separate elements connected. There must be some joint here because the grip is likely folding forward. It's that extra layer. And then again, if we're putting a scope in the scope mount, we're thinking about how do we attach it? Is it attaching by screws? Is it some sort of rigid joint where it slides in? Whatever it is, if you try to think about it a little bit from the point of view of usability and how it's assembled in the real world, this is that layer of believability that we're talking about. Basically, if we delete that layer, all of this would look like the grip is one with a body, which is kind of unlikely in this case. No screws here, just very plain surface, no detail. Again, like, how do we attach it? There's no way. So just some logic in terms of assembly and manufacturing. One last thing before we talk about the references for this gun. Just a good rule for maintaining good design. Complexity only where it's needed. I think I first heard of that rule from Paul Richards' Autodestruct, who said that, like, a design has a business end, and that means basically in this gun, the business end is where the action is happening with the mechanism. So the business end of the gun is really this front, anything past this line. So the complexity is happening in this area, which helps us maintain the 1, 2, 3 read. This is where the complexity is happening. Moreover, the part D is going to be the most detailed part in terms of amount of detail that we add, because this is where the action, once you pull the trigger, this is where you're ejecting the shell, even though, like, some of it is happening here, like the mechanism is there, it's hidden. So whatever we can reveal is happening right here. And then also, because it's a gun, obviously the action is happening here, so we're going to have complexity over here. So, and again, if we have the scope, with our third area of complexity is going to be here. The logic is like, we'll look down the sight, we'll pull the trigger, something's happening, it's firing. The rest is supporting. It's kind of hard to explain. It's some like voodoo logic, but it usually works, because no matter what your actual logic is, as long as it has some sort of logic, I'm talking about your design, the user, the end user, the viewer will be able to see it. If there's no logic, or if the logic is super confusing, the design is going to be confusing. The design always needs to be clear. At least it needs to be easy to comprehend, easy to look at. The 1, 2, 3. So let's in the next chapter, let's take a look at. We're going to take a look at additional tools, but before we do that, we're going to look at some of the references that I'm using for this particular rifle.